In 2010, there's over 250,000 observers right now that have submitted 21.5 million checklists, encompassing over 260 million records of different birds, or different bird species, individual records. Each of those might have counts associated with them too. And so far, 97% of the world's species have been entered into eBird, which is pretty good. And they have almost everything. Some of the ones aren't there, are probably extinct.
Yeah, and critically endangered or extinct.
So they have pretty good coverage, although most of it comes from North America. The United States has submitted 16.6 million checklists, which is 77% of all checklists. And Canada has submitted the next most checklists with 2.3 million. But you can see between the two countries, it's 88% of all checklists are from the US or Canada. So it's a huge data set, and you might ask what can be done with all this data. Obviously, we know there's problems with observer experience, like of all different levels. You have the Great Backyard Bird Count, just beginners putting in stuff, and all the way up to experts. And we saw how like the spatial component of it can be pretty skewed to areas where people live. So what they've been doing at eBird recently, this is kind of their focus on for their future data analysis, is these STEM models. It's called spatiotemporal exploratory models. And so these use these GIS layers, like Dominic was talking about, where they have land cover maps, they have the population maps, other environmental characteristics such as freezing temperatures and growing degree days and all this stuff for different regions. And they use this to predict occurrences of birds outside of where they have data. And so here are a couple plots of some of the stuff they've done. It's really cool what they've been doing. But so this is from two dates, June 30th, two species. The top one's indigo bunting, and you can pretty clearly see that that they prefer to be away from urban areas. Like the white color is areas of low frequency, and dark red is high frequency. And then the chimney swift shows exactly the opposite. They prefer areas with high human populations. There's a lot of nesting sites for them there. And one of the really cool things about these models is that they predict bird occurrence for each species for any time of year, any week of year. And certain birds may change their habitat associations throughout the course of a year. Like for instance, indigo buntings, they usually nest in deciduous forests, but kind of in the fall they move out in the more open, brushy areas, often in fields. And these models will reflect that throughout the course of the year in their migration, where you might expect to see them. And they've used these in the State of the Birds in the U.S. in 2011 and 2013. Like these annual reports, they come out with like the state of the birds in those countries. And what they did, I think one of them was the state of the birds on public lands, and the other was the state of the birds on private lands. And so they used these STEM models to estimate like, the proportion of birds populations that were using public and private lands for all different species. And that is actually a document that's used by a lot of land managers in the U.S. And there's a similar one in Canada that hasn't incorporated eBird data into it yet, but they probably will pretty soon. Yeah, another thing the data is used for is kind of understanding migratory pathways of birds. This is from a recent paper that came out. There's a really good animation on the eBird website. It's just on their homepage. It still should be on the front page, I think. It's a pretty recent paper. But they're looking at migratory routes of 118 different species in the Western Hemisphere, and they were looking at kind of convergence of migratory routes of birds that fly over large expanses of open water. And they showed this really interesting circular pattern, the clockwise pattern that birds take that reflects weather patterns in the spring and fall, kind of how they migrate over large distances. So it's really pretty cool stuff.
They're taking a population centroid at each time interval, so the highest abundancy of the species at a given time to create these tracks. Right?
Yeah.
So this one in the top right is purple sandpiper, okay? So
yeah.
That ends up in northern Nova Scotia. That's kind of the center of the population densities throughout the year.
Yeah, then another thing they're doing now is like they're using weather data from one year to the next, and they're looking at different migratory routes of different bird species in response to weather patterns, and both like the timing of when they initiate flights and also how they ride the winds during these flights. So they're using eBird data a lot for that, in addition to radar data. And one newer thing that they're getting into, it's a little bit harder to calculate, is this abundance mapping. It's like those occurrence maps we were showing earlier, but that was just presence and absence in different areas and how frequently birds are reported. But this actually takes into account the actual counts of birds that people are entering into eBird. So it's a whole other layer of variability there, but they're starting to get some pretty cool results with it. So this is American robins. On the left is in January, and the top is it's logarithmic scale. So it's, on the top is just 1 to 2 birds. Middle is 3 to 100 birds, and 100 plus in the bottom. You can see just kind of where like the concentrations of the large flocks of birds are. And then it's exactly the opposite in the summer. Like in June, you can see like there's 1 to 2 birds just spread out all over the breeding range. They're all in territory, and there are hardly any larger flocks of birds during that time.
Do the maps extend into Canada?
They do. There's
yes,
yeah.
Some of them do. Originally with the STEM models, like a lot of the GIS layers they're a little bit different how they do land cover between the U.S. and Canada, and some of the other covariates they use were missing in Canada. So I mean, most of the data is from the U.S. and it's kind of the modeling they've been doing has been based on the layers they have. But recently in the STEM models, they have incorporated that into Canada. So they must
have incorporated Central America and South America too. So
right.
they're at that point now. There's enough data. And they've, like you said, there's some covariates missing for the habitat layers, but they're
using more like habitat configuration between, so they can get all the Western Hemisphere into the modeling. But eventually they'll get it all. Yeah, together.
It's a process, but it's happening. So take heart. Don't be discouraged by the U.S. centered aspect of eBird. In fact, eBird's growing in South America at an incredible rate. I think at the end there, I'll just show you how many checkles have been entered, say, for Colombia for this month alone, right? It's very encouraging. So, yes.
Yeah. So here's one applied study that they've been focusing on a lot recently. It's called Bird Returns. This is in the California Central Valley. And what it is, a nature conservancy program that they're using eBird data and like analysts from eBird to predict where and when different birds will occur, different water birds. During the late winter and early migration. So they actually, water is a scarcity there. I mean, it's all used in cropland and there's not too many wetlands left. So they're actually paying farmers to flood their agricultural fields sort of short periods of time during the year to provide habitat for these birds during migration. And so they use this eBird data. On the left is the occurrence data. The black dots are the 200 points with the highest occurrence or highest frequency of bird reports. This is northern pintail here, but they have about 20 or 30 different species that they've modeled like this. And on the right is the abundance data, so they're using that new abundance modeling. And the black dots are the 200 points with the highest abundance many. So you can see there's a bit of discrepancy there. I mean, birds are commonly reported in the southern part of the valley, but all the large flocks are pretty much in the north. So they use this from northern pintail and the other species and put it all together and see which areas are the most important for these water birds, and then they pay farmers to flood their fields in that area. It's been really successful. And so, I mean, a lot of bird monitoring in the future is really going the way of eBird. I mean, it's such a huge resource. There's a lot of information there. And as more and more is entered, it becomes more and more valuable. And right now, they did a study on this is in Florida. There's a wetland restoration mitigation wetland that they built there, and they paid surveyors to come and survey it, I think, once a week for the course of the year to see what kind of birds moved in and started using it. But birders quickly took to it too and started eBirding from the same location, and they actually had, I think, 500 check-ins from this location over the course of the year. And these are just like the adjusted species richness, and it matches pretty much perfectly what the paid surveyors found, what was found in the eBird data. So in certain circumstances, the eBird data may take the place of some other surveys of that type. I mean, obviously targeted surveys always exist, but certain things like this can be done using eBird data. So now we'll get on to my current project. I'm working in Phil Taylor's lab at Acadia. And we have a contract through the Canadian Wildlife Service to try and analyze eBird data to extract long-term trends for boreal and Arctic breeding species. So the map here is where all the breeding bird survey routes are in Canada, and the orange is the recently added routes, and the yellow ones are like historical routes. Well, it's still run, but you can see like a lot of the boreal and Arctic region is just not covered at all. So in Canada, like a lot of these species, there's 11% of all species in Canada are considered data deficient, according to the status of cannabis birds in 2014, where they can't even estimate a trend at all, whether it's increasing, decreasing, stable. And then for another 18%, the trends are considered low confidence. Like they have some trend estimate, but it's very, very poor. So what we're doing is we're trying to use eBird data from Canada and the U.S. During the migration season, both spring and fall, to try and determine trends for some of these species. So we'll be looking at black-polled warblers and gray-cheeked thrushes, snow buntings, and stuff like that. And so, I mean, even in the status of cannabis birds, it includes data from like the Christmas bird count and other like areas where these birds winter and whatever data they have, but they haven't gone into the eBird data yet to extract it. And so, obviously, there's a few challenges involved in this really large data set. eBird use has changed a lot over time. On the top graph, this is eBird submissions, number of checklists over the years. You can see pretty much when it launched in 2002, it just took off exponentially. So we're really lacking quite a bit of data before 2000. There are checklists there. I mean, there are thousands per year to deal with, but it's a lot sparser. And then also the way people submit checklists or the way they go birding has changed over time. Shown in the bottom graph, this number of species per checklist. So you can see like in the prior to 1900, in the early 1900s, it's just single species records pretty much entered. And sometime in the 1930s and 40s, you started having some really long checklists with a whole bunch of species, just like maybe people's day lists that they submitted. And then, maybe starting in the 1960s or so, you start getting like this signature of actual checklists. But then you see it's also declining since then too. And I don't think it's because people are seeing fewer birds, it's because people are changing the way they're going birding. They're using more location-specific checklists, like where it used to be day lists, and now it's from more finer and finer scales. So we have some issues to deal with in the data set. That spatial non-randomness issue that we talked about, where people bird a lot or more in urban areas than in rural areas. There's the observer variation, which can actually be modeled pretty well. A paper just came out in 2015. We use species accumulation curves to essentially set an index. You see like, for each observer how many species they see per hour, and you can model that. So each observer gets like a rating in that index, and when they add that to these models, they become way more accurate. Put them into the STEM models. There are also other ways of kind of modeling observer variation in there. And then also, we talked about the different reporting rates between common and rare species. Obviously, like rare species that people twitch or over-reported, and then it's much easier to omit species like starlings. You might just forget to put them on your list. So there's that issue too. And I think that about sums it up.